Hello everyone, welcome to ANT 325. This is Guide to Apache Kafka Replication and Migration with Amazon MSK. My name is Jeremiah O'Connor. I am a Solutions Architect for AWS. I'm joined today by my colleague Priya Chetari, who is an Associate Big Data Specialist, also working with AWS. So to set the agenda for today, we're going to talk a little bit about what is Amazon Managed Streaming Kafka and how can customers leverage it in migrating Apache Kafka workloads into AWS. We're going to talk about some of the native mirroring tools that Apache Kafka offers, as well as some of the reference architectures that we see for common use cases. We're also going to deep dive into MirrorMaker 2 and Apache Flink and how we can leverage those in migration strategies. And then we're also going to talk about Amazon MSK migration and capacity best practices. All right, so first let's set the context for why Amazon MSK. So let's talk a little bit about what the service is if you're not familiar with it and how we can leverage it in our Kafka migrations. So at Amazon, we tend to take a lot of feedback from our customers. And so we started probing the Kafka space to understand what were some of the operational challenges that our customers faced when running Kafka workloads either on EC2 or on premise. And the themes that we heard were very similar. So we heard that it's difficult to set up, right? So provisioning Kafka brokers, Zookeeper instances, managing the connectivity and the configuration between all of them is not a trivial task. In addition, if you need to scale, if you get capacity wrong the first time and you need to scale to add more brokers or to add more storage capacity, again, trying to replicate that data over to new brokers and new instances is not an easy thing to do. Also, it's hard to achieve high availability. So if you're running on-premise, do you deploy your brokers in two different data centers? If you're running in AWS, how do you deploy that across multiple availability zones, or do you do it multi-region? There's a lot of engineering effort that needs to go into place in order to accomplish some of these features. Also, if you want to be able to integrate in with other AWS services, again, there's no, out of the box, there's no integration with that with Apache Kafka. And so you have to leverage things like open source frameworks or third-party tooling. Also, out of the box, there's no console or visible metrics. So again, if you want to leverage those types of capabilities, you have to implement them yourself. And so this little function that we have here is the function of Kafka usage is equivalent to the summation of the work that needs to be done, ultimately by your site reliability engineers. So what we set to do was create a managed service, a managed version of Apache Kafka that helps solve all of these obstacles that our customers ran into. So we created a fully managed, production-ready Apache Kafka cluster that you can deploy as a service within your own AWS account. So we do things like drive best practices through architecture design, through config defaults, and through automation. So if you need the ability to create a secure, scalable, highly available, enterprise-grade, production-level Kafka cluster, you can leverage that all in one central place within the Amazon Managed Streaming Kafka service. We are also committed to improving the open source platform for Kafka, so we are not just consumers of the open source system, we are also contributors back to the open source team. So now I want to talk briefly about what does it mean to mirror data in Apache Kafka and what are some reference architectures that we see customers commonly use. So ultimately, when we talk about mirroring in Kafka, we're talking about maintaining an exact replica of your data from one location to the other. So you may ask, why would we want to do this in Apache Kafka? There's a couple common use cases that we see come up across our customers. So the first is disaster recovery. So if you have production level workloads that you need to have, low RTO, low RPO, you need to have a disaster DR scenario set up. And so typically you'll need to mirror your primary cluster to either another data center or to another AWS region or availability zone. The second use case is aggregation. So if you have multiple different Kafka clusters, maybe owned by different teams or different business units, each with their own set of data, you want to aggregate all of that data into centralized locations. You can run things like business analytics or reporting purposes on top of it. You need to be able to replicate that data from those different Kafka clusters into one centralized location. The other is cloud migration. So if you have the ability to, if you're needing to exit a data center, for example, or if your company is moving all into the cloud, you need the ability to replicate your production Kafka clusters from your on-premise system into AWS. The other is data isolation and geo-proximity. So if you have a use case where your consumers are geographically at a different location than where your primary cluster is, a common use case we'll see is customers replicate that data over to whatever geographic region is closest to their consumers in order to reduce consumption lag. So Apache Kafka has some mirroring tools that we're going to talk about. We're going to talk a little bit about MirrorMaker 2 and some of the differences that make it different from MirrorMaker 1. All right, so first I want to walk through a couple reference architectures for these common use cases that I was just describing. So the first, we refer to this as a hub and spoke mirror architecture. So this is typically used for data aggregation. So in this situation, I've got corporate data centers that are running in New York, in Texas, and in California. And each of them have their own Kafka clusters that are running. They have their own set of producers and consumers, but I want a way to aggregate all of that data into one centralized location, again, for business reporting purposes or data analytics. So in this case, what we would set up is you set up a mirroring strategy to mirror each one of these data centers from our on-premise data centers into one centralized location with Amazon Managed Streaming Kafka. That way, all of the data from all of our different teams or different business units are in one centralized cluster that we can then leverage. The next, we're going to talk about active-active. So if you have a high available application that has very low or virtually zero RTO in terms of what you can handle for failover times, you typically want to run an active-active scenario with bidirectional replication. So in a situation like this, we have a primary MSK cluster that's running in one region. We have a secondary cluster that's running in the other. And then we need the ability to mirror data between the two in the event that one of our clusters goes down. So with MirrorMaker, we call this being paired with a target. So you'll see we actually have two MirrorMaker instances that are running here. The reason for that is that with MirrorMaker, it's a best practice to do what we call remote consume, local produce. So as a best practice, you can actually run two MirrorMaker instances. You want the producer to be local to wherever your cluster is that it's writing to. And you want it to be consuming from the remote cluster. So that's why in this situation, we actually have two. You don't need to achieve the bidirectional replication. You can technically use one, but as a best case recommended strategy, we do recommend having two separate instances of this. So the next, we're going to talk about active-active, but a one-way replication for things like geo-proximity. So in this case, we have our corporate data center, which houses our on-premise Apache Kafka cluster. However, let's say our consumers are in AWS. So we need the ability to reduce consumption lag from our consumers so that they're not having to go either over the internet or over some sort of direct connection back to our on-premise data center. So what we can do is we can, again, leverage a tool like MirrorMaker to replicate that data one way from our Apache Kafka cluster that's running on-prem into AWS so that we can ultimately reduce the lag that our consumers have when consuming that data. The next is going to be active-passive. So this is used for disaster recovery if your application has a little bit higher RTO requirements. So in this situation, we have a Amazon MSK cluster that's running in one region. We use MirrorMaker to mirror that, replicate that data over to a standby cluster in another region. And then, again, that's just one-way replication if we don't have the need to do bidirectional. And so what happens is in the event that that cluster goes down, we can simply take our consumers, flip them over to our standby cluster. Then we could take our producers and flip them over as well. So now we have a successful DR scenario for our producers and our consumers. All right, so next I'm going to kick it over to Priya, who's going to talk a little bit about migration strategies using MirrorMaker 2.
Thanks, Jeremiah. As Jeremiah already introduced about MirrorMaker 2.0, now we'll be having discussion on migration using MirrorMaker 2.0. For that, the first topic we're going to discuss about what are the key differences between MirrorMaker 1.0 and MirrorMaker 2.0. So basically, we're going to understand what is the use case of MirrorMaker 1 and MirrorMaker 2. So let's discuss about MirrorMaker 1. So it's a tool to mirror data between two Kafka clusters. Data is read from topics in source and written with the same name in the destination cluster. So basically, topics are configured with the same default configuration and you need to do repartitioning manually. All the ACL configurations and other configuration cannot be mirrored across the clusters with the help of MirrorMaker 1. So you need to do lot of manual work to map the ACL configurations. Source and destination clusters are independent of each other. But if you want to make any changes to the cluster, you need to bounce the cluster to make the configuration in impact. Now we're going to discuss about MirrorMaker 2. MirrorMaker 2, it's a multi-cluster cross-data replication engine based on Kafka Connect framework. It can detect your new topics and partition in self-discovery mode, so that you don't have to do any repartitioning manually. It can automatically synchronize your topic configuration. It can automatically synchronize your ACL configurations, and your semantic configuration can be intact in this case. It can support active-active cluster pair as well as any number of active clusters. So basically, whatever Jeremiah showed in the previous slides, you can do any disaster recovery scenario with MM2. It can provide you new metrics including end-to-end replication latency across multiple clusters. So you can track your latency with the help of metrics. It can emit the offset required to migrate consumer between cluster and also helps in providing the tooling for offset translation. The configuration file for specifying multiple cluster can flows in one place, so it will be easy to manage with MirrorMaker 2. So MirrorMaker 2 can overcome the limitations of MirrorMaker 1, just like you want to do like the disaster recovery and failover scenarios. Those can be implemented very easily with MirrorMaker 2. So now we're going to discuss about what is the anatomy behind MirrorMaker 2.0. So MirrorMaker 2.0 has three types of connector. Number one, mirror source connector. Mirror source connector is the one where there is a worker which can replicate the set of topic from source to destination. So basically, this is the connector which can be used to replicate your topic from source to destination. Number two, mirrors checkpoint connector. Mirror checkpoint connector is the one where you can send the consumer checkpoint to the destination cluster. So basically, it's the one which can help you in maintaining the replication up to date. Mirror heartbeat connector. Mirror heartbeat connector is the one which emits the heartbeat topic to the destination cluster and can be help. It can help in demonstrating the connectivity between connector and sources and destination cluster. So basically, with the help of those three connectors, it can be very easy to maintain multiple data replication between multi-node clusters. So this is now we'll be discussing about what are the deployment methods behind MirrorMaker 2.0. MirrorMaker 2.0 can be deployed and run with 4 ways. Number one, dedicated MirrorMaker 2.0 cluster. In this mode, if you don't have any Kafka Connect cluster present, you can use high-level driver to configure MirrorMaker 2.0. Number two, connector in a distributed connector cluster. In this mode, basically, if you already have a Connect cluster, you can utilize that Connect cluster to configure MirrorMaker 2.0. Number three, as a standalone Connect worker. In this mode, basically, if you have a single Connect cluster, you can configure it with mirror source connector, which we discussed in our last slide, and can be used for single node clusters. So basically, if you want to use it for single node cluster, it is good. Basically, if you want to do some lower level testing, you can use it for the single node clusters. In legacy mode, basically, if you have a MirrorMaker which is getting deprecating, so you can use those shell scripts and update it, and you can use those shell scripts with MirrorMaker 2.0. So those are the 4 deployment methods which you can utilize and deploy it with MirrorMaker 2.0. Now we'll be focusing on 2 different migration scenario where you can find the significance of MirrorMaker. So in the first scenario is no retention migration. If you have a use case when you don't want any data from source to destination, and there are use cases like you have log data, you don't have any significance of history data, what you can use, there is no need of MirrorMaker over here. So in those cases, what you can do, you can move your producer and consumer to the destination cluster, and it will take care of all the set configurations. And once you check all the configurations and correct, then you can decommission your source cluster. So like this. So basically, there is no need of MirrorMaker when you are not willing to copy any data from source to destination. And also make sure that the producer and consumer are configured with the latest configuration, so that the only latest data will get moved from source to destination. In the second scenario, when you have a use case like you need very minimal downtime and you want all the data from source to destination, you can use this particular method. In this particular method, first MirrorMaker has the major role to be played, because we need all the data from source to destination. So in this case, first we'll be setting up the MirrorMaker, and MirrorMaker will be set up between source and the destination. Once the MirrorMaker is set up properly and all the configurations are configured for MirrorMaker, then what you can do, you can stop the consumer. Once the consumer is stopped, then we will be waiting for the consumer offset to get synced between source and destination. So let's wait for that. And once the consumer offset is synced between source and destination, then we can move our destination to the consumer to the destination cluster. Now ensure that all the data is from producer of the source cluster is consumed by consumer of the destination cluster, so that there will be no data losses. Once that is confirmed, then we're gonna wait for all the lags to get complete. And we'll be stopping the producer so that there will be no messages will be flowing from producer anymore. And once the producer is stopped, then we're gonna wait for the data to be synced up between producer and consumer, and there will be no data losses and there should be no lags. So once the lag is 0, then we can move our producer to the destination cluster. Now we have all the setting of producer and consumer, and we need to make sure all the data is flowing from producer to consumer by using Amazon MSK. Once that is configured, then we can decommission our MirrorMaker and we can decommission our source cluster. So these are the two methods which you can utilize for migration of consumer and producers. Now I'm handing over to Jeremiah for further migration using Apache Flink.
Thanks, Priya. So now I want to deep dive a little bit on migration strategies leveraging Apache Flink. So when most customers think of Apache Flink, they don't think of it as a replication service. It's typically thought of as a big data streaming platform where you can consume data in from streams, perform ETL or manipulations, and then ultimately ship that transformed data to another location. But today we're going to talk a little bit about how we can actually leverage Apache Flink for migrating data between Kafka clusters. So first, let's talk about the differences. So Priya just talked about MirrorMaker 2 and some of the features that it offers. I want to talk about what makes Apache Flink different. So Apache Flink, again, is a streaming data platform that is used to enrich data from the time that it's pulled in from a stream to the time that it produces data somewhere else. So this is very powerful if you have a workload where your on-premise or your default Kafka cluster has data that needs to be changed before you're actually ingesting it into your default or your destination cluster. So with Apache Flink, you can actually leverage Kinesis Data Analytics to host your Apache Flink applications. So what this allows you to do is this allows you to have a serverless infrastructure so that your teams don't have to manage any underlying infrastructure for your Flink applications. Also, hosting Apache Flink on Kinesis Data Analytics allows you to leverage the auto-scaling features that Kinesis Data Analytics offers as well to achieve increased throughput requirements depending on what your migration is. Apache Flink is also great in that it's a little bit more flexible than MirrorMaker in terms of you're allowed to have different types of syncs and producers on your cluster. So if you need the ability to stream data from Kafka to, let's say, Elasticsearch or to RDS, Apache Flink has a multitude of different sync and source connectors that allow you to sort of plug and play what your use case is. It also supports exact want semantics depending on the source and destination engine. So if you're doing Kafka to Kafka, it does support exact want semantics if that is important for your use case. Now, we've been talking a lot about the advantages of Apache Flink, so you may be thinking to yourself, well, why would I use MirrorMaker? Well, Apache Flink is just used for migrating data. So if you need to migrate consumers in real time, you need to migrate consumer offsets, schema information, ACLs, any of the metadata that's not associated with the actual just raw data itself, Apache Flink is not available to do that out of the box. And so in order to migrate that type of data, you'd have to use some sort of third-party solution. Now, MirrorMaker can be run in a multitude of different methods, as Priya mentioned in the previous slides. It supports at least want semantics. In addition to that, in addition to data migration, I should say, it allows you to do migration of ACLs, topic configs, it's really the full solution in terms of mirroring data between two Kafka clusters, especially if you're needing to migrate producers and consumers over. MirrorMaker 2 also does support bidirectional replication. So if that is a requirement for, like I showed in the reference architecture for your high availability scenario, you can leverage that as well, whereas Apache Flink is only one-way replication. So let's walk through a use case, a reference architecture, to talk about how we can leverage Apache Flink to migrate data. So for this particular use case, we have an on-premise Kafka cluster that houses all of our data. Now, we want to transform that data before it goes to our Amazon MSK cluster. So we want to manipulate that data in some way. We either want to enrich it, maybe filter out some fields, maybe do some transformations on it. So we're going to leverage Apache Flink running on top of Kinesis Data Analytics. So the first thing we'll do is we'll provision a new Kinesis Data Analytics application, and we'll select Apache Flink as our runtime. Then we establish a source connector to our on-premise Kafka cluster. We establish the sync connector to our Amazon MSK cluster. We take our Apache Flink code, and we need to upload that jar file or that zipped jar file to S3. And then we simply need to point our Apache Flink application to know where to pull that code from S3. And then all we need to do is simply press start. And Apache Flink running on Kinesis Data Analytics will handle the rest. So what will happen is Apache Flink will pull data in from the source connector. It'll run through n number of operations in order to do our enrichment or our transformation. And then ultimately, it will digest that information into our Amazon MSK cluster. So at this point, we can actually stop our consumers that are running on our on-premise Kafka cluster, and we want to spin up new consumers that consume the newly transformed data. So in this case, we want to spin up new consumers that are reading from latest, as we want to make sure we pull all the latest data that's coming in from our Amazon MSK cluster. Now, at this point, we can actually stop the reference architecture if we wanted to. So if you still have a use case where you need to produce on-premise to your on-premise cluster, but you still want to be able to do those transformations before you ingest it into your Amazon MSK cluster, you can just leave this exactly as is. However, if you do want to eventually move over your producers and maybe decommission your on-premise Kafka cluster for cost-saving purposes, for example, then what you need to do is you need to create your new producers that are going to be producing the newly transformed data. You can then stop your producers on your on-premise Kafka cluster. You want to wait at this point to make sure that Apache Flink has migrated all of the data successfully over from your on-premise cluster to make sure there's no data loss whatsoever. And at that point, you can feel confident decommissioning your on-premise Kafka cluster. So I want to talk real briefly about some of the advantages of running Flink on top of Kinesis Data Analytics. So Kinesis Data Analytics out of the box really gives you a fully managed platform for hosting Java and SQL Flink apps with virtually no overhead whatsoever. So you simply need to write your code, upload it to S3, and then press start, and Kinesis Data Analytics handles the rest. So it still gives you that real-time processing, that millisecond latency for production environments, for enterprises that require very low latency stream throughput. It also is automatically elastic, like I was mentioning. You can automatically scale to meet your migration throughput requirements. It's very simple to use and stand up. And because it's a managed service by AWS, it is tightly integrated with other AWS services. So if you want to be able to leverage things like IAM for permissioning, putting data in S3, all of those are tied into the Kinesis Data Analytics application. And then ultimately, you're only paying for what you use. So if you just need to stand it up for use during a one-time migration, when you're done, you're only paying for that application as you're doing the migration. When you're done, you simply turn it off, and you're not accruing any more costs. So now I'm going to kick it back to Priya, who's going to finish up talking about Amazon MSK migration and capacity planning best practices.
Thanks, Jeremiah. Now we are moving to our next topic, which is Amazon MSK migration and capacity planning best practices. So let's discuss about that. Let's discuss about capacity planning best practices. So there are two primary decisions required in terms of capacity planning. So basically those are: what should be the instance type of the broker which we need to use for our workload? And the second one is capacity planning, actual planning of number of brokers for Amazon MSK. So let's discuss about instance type of the broker. Amazon MSK supports M family and T family of Amazon EC2 instances. So basically M5 broker can provide you more partition than T3. M5 can be used if you're running very large production grade workloads, or if you require a greater number of partitions. So the second one is capacity planning for Amazon MSK. Amazon always recommends to use MSK sizing and pricing spreadsheet to determine the correct number of brokers for your MSK clusters. So this is a spreadsheet where you need to provide all the important parameters, like what should be the replication factor you needed for your workload. The second one is like what should be the retention of the messages you needed. On the basis of that, you can get an estimate of number of brokers you want to require for your cluster, as well as what should be the ideal size of the broker you needed for your workload. So those two can be calculated easily with the help of MSK sizing and pricing spreadsheet. And after you have decided on number of broker, you can test to validate assumptions. So basically that the spreadsheet can give you the estimate of that work, estimate of the number of brokers and the instance type, and you need to test it and validate your assumption before moving forward to the production workloads. So this is a spreadsheet which we were talking in the last slide. So basically in this slide, in this spreadsheet, basically if you need to enter these particular parameters like ingestion rate, replication factor, retention per hour, and on the basis of that, there is a logic behind this spreadsheet and which can provide you customer cluster instance type, cluster size, and also provide you the pricing model, which you can use it to find out what are the prices differences you can get it with the change of the parameters. Now, summarizing the sizing guidance, basically the calculator which we have discussed in our last slide is the it can estimate your workload needs. Those costs are normalized to per $GB ingestion to make price comparison easy. So you can compare your pricing on the basis of changing the parameters, and you can have the estimate of your pricing very easily with that spreadsheet. Your latency requirement will impact how much you should provision. So you should adjust that accordingly. And we always recommend that you test your workload and scale up and down according to your workload. In the end, I want to reiterate that you can save up to 40% lower cost as compared to self-managed Apache Kafka. So basically, if you are using Zookeeper, there are no extra charges are there with Amazon MSK. And also cross availability zone replication also has no charges with with Amazon MSK. So those are the reasons it can reduce the cost up to 40%. As we are moving to the end of our presentation, I would really like to thank Mr. Rajiv Chakravarti for giving the content for this presentation. And also, I would really like to thank my audience for their valuable time. And also, please complete the session survey in the end. Thank you.